Heralding a new age in the cosmos, Norwegian Christian Birkeland predicted that the universe likely consisted of an exotic component that would later be called dark matter. His comments about this subject matter appeared in a description of the Norwegian Aurora Polaris expedition 1902–1903. Birkeland's ideas about the expedition were published in the fateful year of 1913, which would see the rise of the Socialist Federal Reserve System and the income tax in the United States of America, two key components of the Communist Manifesto. Evolutionary processes were in motion throughout all fields of endeavor. Economics, politics, science and the hearts and minds of men and women were in the balance, whilst relativism not truth held sway over the modern imagination. Cosmology would suffer from the same evolutionary mindset, and Birkeland wrote as much. We have assumed that each stellar system in evolutions throws off electric corpuscles into space. It does not seem unreasonable therefore to think that the greater part of the material masses in the universe is found, not in the solar systems or nebulae, but in empty space. In this fashion, Birkeland predicted that because of the evolutions present within the cosmos, most of the matter in the universe must be found in empty space rather than that which is observable in stellar objects. It is currently believed that only 4% of the universe is of this ordinary visible stellar type. Further, about a quarter of the universe is made up of the ubiquitous dark matter, with the rest of the cosmos being filled with the even more bizarre dark energy. It was Fritz Zwicky, a Swiss astrophysicist working for Caltech, who would further the concept of dark matter through the aegis of the virial theorem. This mathematical relation is a formula which bounds the energy of a set of particles. In another dark year in the steady evolution to slavery since 1933 saw the removal of gold from the accounts of American citizenry, Zwicky used the virial theorem in an attempt to ascertain the validity of the dark matter hypothesis. He focused his attention on the Coma Galactic cluster, and his analysis provided prima facie confirmation for the existence of dark matter. By evaluating the amount of movement of those galaxies at the periphery of the cluster, he was able to approximately surmise the aggregate of all the matter therein. He was astonished to learn that this sum total of mass is different from a separately computed estimate. This other value was obtained by analyzing the sum total of galaxies and the brightness of the Coma cluster. Juxtaposing this value with the periphery computation, he observed that there was a discrepancy of at a minimum 400-fold. Since the galaxies were insufficiently massive to cause the computed orbital velocities, there must be some other mechanism to explain this phenomena. This conundrum became in the scientific lexicon the missing mass problem. Zwicky had established the need for the existence of an invisible source of mass hitherto unknown, which must provide the necessary gravitational effect for the cluster. Thus, it is a fact of the current state of cosmology that the greatest set of evidence for dark matter comes from this galactic gravitational data. Scientists have even made galactic curves describing the rotational properties of stars versus the distance from the galactic center. When the gravitational data is plotted, it can be shown that only a small portion of the observed speeds are explicable by classical computations. In other words, there is a scarcity of visible mass in the observed galaxies to attribute the sum total of gravitational effects to visibly observable stars, planets and galaxies. Thus, the simplest way to explain this galactic mystery of insufficient mass is to hypothesize a non-detectable type of mass known as dark matter, which can be the cause for the gravitational effects. As more and more data is collected on these and other aspects of the universe, formulae and cosmological postulates are generated describing the results so obtained. Fulfilling the requirements of the aforementioned aspects leads some scientists to propose several different types of dark matter. The four main types of dark matter are called 1 baryonic dark matter, 2 warm dark matter, 3 cold dark matter and 4 hot dark matter. Dark matter ranges from the known to the predicted, from black holes to brown dwarfs to the massive compact halo objects, machos, the neutrino, axions, WIMPs or weakly interacting massive particles, and the esoteric neutralino. However, there is an alternative explanation for the gravitational effects which originally created the dark matter concept. If an incomplete understanding of gravitation is factored into the picture, then it can be asserted that the dark matter interpretation is incorrect because some other cause is generating these phenomena. Several different contending theories have been developed to describe the observed galactic data. In particular, one of the main competing explanations is given by scalar tensor theories, which try to combine the teachings of quantum mechanics with gravity. Amplifying these ideas leads to a variety of exotic ideas which challenge our most fundamental notions of physics and astronomy. Other concepts go even further and have been the subject of interest for astronomers like Dr. Riccardo Scarpa, since these allow for a cosmology without the inclusion of the enigmatic dark matter. Dr. Scarpa works at the European Southern Observatory in Santiago, Chile, using the Very Large Telescope Array at Paranal. With all of his experience in this field, it is interesting to note some of his most recent comments on the superfluous dark matter. Dark matter is the craziest idea we've ever had in astronomy. It can appear when you need it, it can do what you like, be distributed in any way you like. It is the fairy tale of astronomy. In view of these comments, one should ask if another scientific idea might be on the verge of collapsing. Indeed, astronomers are routinely using these other theoretical principles on a daily basis in infrared observatories around the world. Thus, it is very likely that we are simply wrong about all of this dark matter. It is within all probability that the only dark matter that we will ever find is that ignorant dark matter between our ears.